Hello and good evening, CSI135 Section 400 Introduction to Linux students for the fall 2013 semester. This video is your solution set for quiz for lab number 5. All right, the first question asks you, what is the plan for user TPB? And you would simply use the finger utility and then the login ID of the individual. And as you can see, TPB has no plan. So the answer to number 1 is no plan. All right, in your home directory, create the following directory tree. Now, you could do this two ways. You could use the -P option, or you could create the directories individually one at a time. The most effective way to do this, or the quickest way to do it, would be to do the makedir with the -P command. And I'm actually going to go ahead and cut and paste this. Let's copy and paste this. It says the permission for these directories, including your home directory, will all need to be 755. How can you accomplish the above in a single command? Well, the default permissions when directories are created is 755. So the command as it's written, makedir -P, will create that directory structure. So now you can see I can move down here into labs, week 6, and my labs, right? Okay, so it was makedir -P. And again, the -P option for makedir will create the parent directories that are required all the way down the directory path. Okay, using the Vader system, user log, provide the full name, office number, and login shell for the user who's connecting to the Vader system from IP address 108.15.98.136. So you could do the last -DW, I believe it's DW, and we're going to grep for 98.136, and let's see what we get. All right, so it looks like we've got one user in particular who's coming in from that address, and it's RHS. And we'll let this finish out. And if you do a man on the last utility, I think it might be a -I. Yeah, so this option's like -D in that it displays the IP number of the remote host. So if I were to run that same command again, and let's use -IW, you can see it runs much faster, but again, it does make that same match. So we'll use the finger utility against the user RHS, and this is the plan for Dick Seabrook, who's located in Cal 999, and this is his plan. All right, so that would have been your answer. Number 4, at what email address can you contact the author of the utility last? So we'll type in man space last, and we know that the author section's at the bottom, and there's your answer right there. Michels@sistron.nl. All right, so that's your answer for number 4. Number 5, it says in the directory that you created in step number 2, right, and I'm actually already there, so there's the directory we created. It says create a shell script in the bash shell with the name question5.bash. The script will need to perform the following tasks: clear the screen, print a welcome message, show the current system date and time. All right, so we're going to vi QUES5.bash. Oops. QUES5.bash. Now remember, we want to have the magic number followed by the absolute path name to the bash shell. It's always a good idea to put some comments at the top of your shell script, right? And we'll say today's date is the 6th of October, 2013, and title. So we'll name this script when we're done. Well, actually, we've already named it QUES5.bash. All right. And so now onto the script. So the script will clear the screen, print a welcome message, and then print the current system date and time. And that's it. And I typically like to put a closing message at the end so that the user knows that that's the end of the file. Okay, so that's it. We clear the screen, we echo welcome to my script, we run the date command, and that's it. So that would be number 5. So let's save it. Right now there's two ways we can run this. I can simply type in bash question number 5.bash. As you can see, it cleared the screen, it printed the welcome message, and it printed the current system date and time. Now, if I type in, if I type in question5.bash, and try to run it, as you can see, it says permission denied. And this is where we would need to do the change mode command, and I usually do u+x question5.bash. So that way if I run it again, now it'll run by simply giving it the name. The reason it didn't run before is that the execute bit was not set, because by default, when we create files on the Vader system, due to the umask setting in the .bash_profile of 022, all files that we create have a default permission setting of 644. Okay, so that would have been number 5. All right, so number 6, in the directory you created in step number 2, create a shell script in the bash shell with the name question6.bash. So now I'm going to copy question5.bash over to question6.bash, because this is already going to give me all of the comments at the very top, and I only have to change a few things. Now, this says create a shell script in the bash shell, and the script will need to perform the following tasks. Display only the line with the name Death Star out of the etc hosts file. Okay, so we'll come down here. Whoops. Got the caps lock on there, so I'm going to quit out. And we're going to vi question6.bash again. There we go. Okay, so same title. Same author, same date. Let's change the title. And this is simply going to cat the etc password file, and we're going to grep for, and we'll do a -i just in case, Death Star. Death Star. All right, so this is a valid shell script, and since we copied it, let's see if the permissions are the same. They are, so I could type in question6.bash and hit enter, and we have no match. Let's cat the etc password file. Oh, I'm sorry, etc hosts. Yeah, so Death Star is there, so let's call our script back up, and I went into etc password, I wanted etc hosts. Let's change word, and then we'll type in hosts. So now we'll save it. We should get a little better results. So we'll do question6.bash. Keep hitting the caps lock key. So question6.bash, and as you can see, there's the line with just Death Star, and that's the IP address. So that would have been your answer to number 6. Number 7, create a function in your .bash_profile that performs the following tasks, and you can name the function anything you'd like. Print the current system date and time, and we know that you can do that with the date command, and then print a list of the users currently logged onto the class system Vader. And we could use a number of commands there. We could use who, we could use w, and so let's go ahead and create this. So .bash_profile. As you can see, I have a function here called who's on, and so I think I'll leave it with that. And so then we're going to delete that line and print the current system date and time, so date, and I'm going to go ahead and I'm going to use who. Okay, so that's what the function would look like. It's called who's on. We have open parens, close parens. Then we have the open brace, and this is where we're going to put our commands, and then the close brace to let the bash shell know that that's where the function ends. All right, so now if I save this .bash_profile, and this is critical, if I were to run who's on right now, you'll notice that it shows me who is logged on, but we're not getting the current system date and time. And the reason for this is because we need to reread or source the .bash_profile file in order to get those changes read into memory. So I'll do a ./.bash_profile. And the reason I can do this command as opposed to this command is because this command requires me to be in the directory, right? So I do ./, and that / says the current working directory, and then the .bash profile. If I'm not in my home directory, which is where the .bash_profile is located, I can use the tilde here instead of the period. So again, the period says, hey, I'm in the current working directory where this file is located. But if I'm not there and I make a change, I can simply use the tilde to represent the absolute path name to the home directory. And again, both commands are legitimate commands, but remember, when you use the one with the period, you need to be in the home directory or the directory where this file is located, and 99.9% of the time, that is your home directory. So now we've reread the .bash_profile. We've sourced that file. So now if I type who's on and I hit enter, you can see that the date is now printed here at the very top of the command, right? All right, fantastic. So that is your answer to number 7. Okay, number 8 says using only a pipeline, create a command that will result in the following output. It says it needs to match exactly. So let's take a look at this output here and let's see what we can find in common. Now obviously this is the Etsy password file. You'll notice that you've got 7 colon delineated fields. And if I'm looking for something in common here, I can see right away at the end, the 7th field, which is the default login shell for each of these users, is the TC shell. So if I cat the Etsy password file and I grep for TCSH, let's see what we get. All right, I get WP Bryson, AJW, Kathy B, and TLC. Now this number 8 here, it says needs to match exactly. So I see that they've got the TC shell, so I can match on that, and we've done that. But you'll notice mine are not in the same order. In fact, it looked initially like it could be reverse alphabetical sort here, but it's not, because it goes W-A and then C and then T. When I look down here, it needs to be reverse sorted. So what I could do is type sort space -R, and let's see if that matches. And it does. You can see we now have WP Bryson, TLC, Kathy B, and AJW, and this matches exactly. So this is certainly one way to do it. Another way to do it is if I was to cd into the Etsy directory, I could simply type grep TCSH from password, and then type it to sort -R, and that would have the same results, right? So if you're not in the Etsy directory and you just simply want to cat it out, you can certainly do that. And this is also a legitimate answer for that question. All right, and that was number 8. Number 9, it says now in the directory that you created in step number 2, and so we're going to cd back into CSI135, in the Etsy directory. So I'll cd into CSI135, and then this directory was called labs. And then cd week number 6, and then I think it's my labs. Okay. It says create a shell script that does the exact same thing that you did in step number 8. The name of the file must be question9.bash. So I'll just copy question6.bash over to question9.bash. And again, the reason for doing that is because I've already got my comments in there. I've got my date, my time, my title. I just need to make a few minor adjustments. And I'll come over here. The title of the script is now question 9, right? So we'll delete that line, and then I'm going to insert the new line in here. I'm going to roll back up, and I'm going to grab my command, and we're going to do this, right? Because we want to give the absolute path name to the password file. And the reason for this is because I may not be in the Etsy directory when I execute this shell script. So I want to make sure I provide the absolute path name to the password file. Okay, so now I'm going to save this file, clear my screen. We'll give a long listing here, and you can see again, since I copied the file, the permissions are the same, 744. And now if I run question9.bash, you can see that it does the exact same thing. And again, this is to get you into the habit of realizing that you can actually take individual Linux utilities or Linux commands, put them into a single file, and you've got yourself a shell script. All right, now in your .bashrc file, create an alias that does the same thing as the pipeline shell script from numbers 8 and 9. And that's the same command that we just ran up above. You can name the alias anything you'd like. So I'm going to get into my home directory. I'm going to VI my .bashrc file. You can see I have some aliases in here already. So I'll create another alias. It's going to be called TCS. Well, I don't want to call it. I'll call it TC. And what this command is going to do is what my previous command did, which is cat the etc password file, grep for tcsh, the tc shell, and that's going to reverse sort. So let's go ahead and save this, and let's see if this works. So again, I have to source the file, right? Because if I type tc right now, the command is not found. It's not going to work. So if I do a ./.bashrc and hit enter, that's one way to reread the file. If I was in the temp directory and I run that same command, I'm going to get an error, right? Because I'm not in the directory. And again, that's what that period right here represents, is the current working directory, and that's your delineator, and then the .bashrc file. So this is where we would want to do the ./.bashrc, because remember, the tilde is the representation of the absolute path name to your home directory, and so that would work. All right, so I'll cd back into my home directory. I'm going to clear the screen. So let me cat the .bashrc file and see what we have in there. So if I type in tc now, right, you can see I created the alias tc, and you can also create an alias. So if it's a short command, you can get away with doing an alias. So if you're prompting for input and you're processing that input and creating variables, you definitely want to use a shell script. But an alias can also work to save you some keystrokes, because instead of having to type that whole command out, I just type tc, and then it shows me exactly what I want to see. So that would be your answer to number 10. All right, number 11. Using the etc password file, create a pipeline of commands that will result in the following output. And it needs to match what you see below exactly. So by just taking a quick look here, I can see that it looks like this has been reverse sorted, but not numerically, right? It's definitely not numerically reverse sorted, but it's definitely reverse sorted. So it starts from 200 and goes all the way to 0. So the etc password file, so let's take a look, and we'll do more on etc password. And let's see what we've got here. So obviously, where are these numbers coming from? They certainly could be the user ID, it could be the group ID. And let's go ahead and take a look here. So if I were to cat the etc password file, and then I'm going to do an awk. And if you remember from the other week, if you do -f:, that's the delineator of the fields. So I'll do a print $, and let's do 3. Take a look at the third field first here. And let's see what we get, and I'll pipe it to more. All right, so there are a lot of my numbers that I've been seeing. Okay, so now that I've got this, how about we sort those numbers? Oops, let's run that again. Pipe it to more so we can slow it down a little bit. Okay, so once I sorted those numbers, I can see there's 200, 2, 190, 188. So, but I'm looking for, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm looking for 15 lines, so those first 15 lines. So if you remember, when I pipe it through sort, I could also do head-15, and let's see what we get. All right, so there they are. Now, it looks like I only need to do one more thing. And actually what I'm going to do is, let's back up here, do sort-r, and then head-15. And no, that doesn't work. So I can't reverse sort first. I've got to sort those out right away. And then we'll do head-15 and pipe that to sort-r, and let's see if we get what we're looking for. And we do. 202, 190. So this is the command that would be required to pull those numbers out of the third field. Okay, that was number 11. Number 12. Now, in the same directory you created in step number 2, create a shell script that does the exact same thing you did in step 11. So this command right here, so we're going to copy that guy. It says the name of the script must be question12_uids.bash, and it says hint, use the awk command to define the field delimiter and the field you wish to use. And so that was where we did the awk-f with the colon, and then we printed the third field, which is your user ID field. Okay, so we've got that command already, so let's cd back into CSI135, and this was called labs, and was it my labs? No, let's see what we've got here. Week 6, and then I think my labs. There we go. Okay, so I'm going to copy question 9.bash over to question 12_UIDs.bash. All right, so I'm going to VI question 12, and again, it's convenient. I've got all my things here. All the comments are dialed in, _UIDs.bash. I'm going to come down. I'm going to pull that out of there and paste in. Whoops, and only grab that part. So let's get rid of that. Scroll up a little bit here. Let's get the whole command. There we go. So copy, and we'll come down here and paste. Whoops. Now let me pull back that space. Okay. So now if I type in /question 12_UIDs.bash, there you go. All right, and so that was the answer to number 12. Number 13, what does grep stand for? It stands for Global Regular Expression Print. Number 14, when it appears in the first line of a shell script, what is the following series of characters referred to as? So that #bang is the magic number. Very important that you remember that, the magic number. And what follows that magic number is the absolute path name to the shell that you want that script to be executed with. And this is critical because if you write the script in the bash shell and you have bash specific syntax in the file, you want to make sure that it's calling the bash shell to run it. Because if a user who's running, let's say, the C shell tries to run that script and you don't have the magic number followed by the absolute path name to the shell that you want that script to be run with, the C shell will not be able to interpret that file or the bash specific command syntax in that file. All right, number 15. What is the difference between the two commands, /myscript or bash myscript? So the first one is going to use the current process, the current shell process that you have, your login shell, and it's going to run that command. The second command here, bash space myscript, this is going to run the script, but it's going to run it in a subshell because you're calling the bash shell an instance of the bash shell to be started to run my script. All right, describe what the following commands would match in a directory. So the first one will match any two characters followed by a lowercase or uppercase letter followed by 0 or more of any character. The second example will match any file name that begins with a period followed by any two characters followed by a lowercase letter G through Z followed by any one character. But it has to be at least one character. Remember, the question mark has to match something, right? It has to match something. So the third one would have to match a single character followed by a period, followed by any single character, followed by a period, followed by any single character, followed by 0 or more of any character. And remember, that's the asterisk, is 0 or more. So the asterisk, unlike the question mark, does not have to match something. All right, D would be a file name that begins with ... followed by any single character, and then any single character, and then a number 0 through 9. E will match 0 or more of any file name. And finally, F is going to match any file name that begins with a period, followed by a lowercase letter, any lowercase, single lowercase letter, followed by any single digit 0 through 3, followed by any two characters, followed by any capital letter A through Z. All right, that's your solution set for lab number 5. All the best of luck, and don't forget we have our midterm on Wednesday, and we'll be starting at 6 o'clock sharp. I'll see you there. Enjoy the rest of your weekend.